Okay, I'm gonna grab a piece of paper, and today we're going to talk about the different functional groups. Remember, for class, I only had you learn 4 of those functional groups that were listed in your chapter. So let's begin by drawing each one of those. Okay, the first one that we're going to draw is the hydroxyl group. We know that the hydroxyl group is simply an OH group. We'll find the hydroxyl group on sugars. Remember, hydroxyl groups tend to make things polar. If you take sugar, remember, for example, if you were in lab, you could take sugar and dissolve it into water because of it. Both of those solutions have some polarity to them. So, and this guy is covered with these hydroxyl groups. All right, the next group we'll look at is a phosphate group. The phosphate group is a group that we'll find on phospholipids. For example, we'll see it on ATP. As a matter of fact, ATP has triphosphate. So not only does it have one group, it has 3 of them. If you remember from lab, you found out that DNA has at least 1 phosphate group. So we'll find the phosphate group on phospholipids. We'll find them on DNA. We'll find them in multiple places. So let's draw that. We have this phosphorus atom that's double bonded to an oxygen with these hydroxyl groups out on either side, and also covalently bonded to the bottom. Make sure when you're drawing your groups, you always keep the oxygen on that bond. The oxygen belongs on the bond. Do not flip it around and put the hydrogen in the other place. So we want to make sure all these oxygens are bonded on the bond. Okay, just so you make sure you understand what we don't want. We do not want. Let me see. Can I just erase this one? We don't want to place this incorrectly by putting an H and an O there. Okay, so we want to make sure that we always put an O and an H. Okay, so we want to always do an O and an H. Okay, the next group. Oh, and one of the other things we want to remember: phosphorus is one of those funny guys who has access to another orbital. So he has access to a d orbital. That's the reason why you see it has these unusual 5 bonds. Remember, we've been trying to keep this number correct by saying we have 2, 4, 6, 8 atoms. This guy has 10, and it's because he has access to a d orbital. All right, instead of just the S and the P. All right, let's move on. We want to, and phosphate groups, again, remember they make things polar as well, as we saw on the phospholipid that we drew in class. All right, so we said now we want to do an amino group. Amino group, we will find, for example, on amino acids, the amino group is an N with an H and another H. So also covalently bonded to 2 hydrogens. So that's our amino group. And then finally, we have a carboxyl group. And let's grab one more sheet of paper and draw carboxyl group, and that's a C double bonded to an O with an OH group. Okay, so that's our carboxyl group. Remember, we can flip that around, same as any of these other guys, but we can flip that around and we can draw this also C double bonded to an O, or we can put the OH group in that position. But remember, carboxyl groups makes things what? Acidic. So carboxyl groups make things acidic. Okay, well, that concludes the 4 functional groups that you were to learn for this test that's coming up. Hope you have a wonderful day. Goodbye.